In a world where the specter of nuclear warfare looms, understanding the most deadly and destructive weapons at humanity's disposal is crucial. The development and proliferation of nuclear weapons have fundamentally shaped the geopolitical landscape, creating an ever-present threat capable of unimaginable devastation. In this video, we delve into the realm of nuclear armaments and explore the top 10 deadliest weapons currently in existence. From intercontinental ballistic missiles, ICBMs, to advanced warheads, these weapons possess the capability to unleash catastrophic destruction on a global scale. Join us on this sobering journey as we shed light on the most lethal nuclear weapons that humanity has ever created. Number 10. Mk-14 Nuclear Bomb, 6.9 megatons. The Mark 14 nuclear bomb, also dubbed the Mk-14 or Texas 14, was an American thermonuclear weapon designed in the 1950s and was the first solid-fuel staged hydrogen bomb in the world. As an experimental weapon, the United States only produced 5 of these bombs by 1954, testing the device in April of that year during the Castle Union nuclear experiment. During the Castle Union nuclear test, the Mk-14 was successfully detonated with a yield of 6.9 megatons. In terms of size, the Mk-14 was approximately 328 times more powerful than the atomic bomb, Fat Man, dropped over Nagasaki in 1945. Despite successful tests, the Mk-14s were retired later in the year because 5 megatons of its total power were derived from fission reactions. As a result, the weapon was considered very dirty, referring to the tremendous amount of radiation dispersed from the device after detonation. Number 9. Mk-16 Nuclear Bomb, 7 megatons. The Mark 16 nuclear bomb, also referred to as the Mk-16, Texas 16, or EC-16, was a large thermonuclear weapon based on the Ivy Mike hydrogen bomb. The weapon was the only thermonuclear bomb ever developed to use cryogenic deuterium fusion fuel. Due to the number of vacuum flasks required for this type of fuel, the bomb was extraordinarily large, weighing 42,000 pounds with a length of nearly 25 feet. As a result, a specially modified B-36 was the only American aircraft capable of deploying the weapon. Although tests of the Mk-16 were planned to take place during Operation Castle, the success of Castle Bravo's shrimp device made the Mk-16 relatively obsolete in the eyes of the American military. Number 8. B-53, Mk-53, Nuclear Bomb, 9 megatons. The B-53, also known as the Mark 53, was a bunker buster thermonuclear weapon developed by the United States military during the 1960s. The bomb was first designed in response to the deep underground bunkers constructed for Soviet leaders during the Cold War. Using a surface blast to collapse the surrounding Earth onto its target, the bomb was designed to inflict massive damage on underground centers, giving the United States a decisive edge in the event of nuclear war. At this yield, a B-53 detonation could destroy all structures within a 9-mile radius, with severe burns possible as far as 20 miles. Depending on terrain, researchers believe that casualty rates within 2.25 miles of the blast would be in the vicinity of 90%. Number 7. Mk-36 Nuclear Bomb, 10 megatons. The Mk-36 nuclear bomb, also known as the Mark 36, was a high-yield thermonuclear weapon first developed in the 1950s. Using a multi-stage fusion system comparable to the Mk-21, the Mk-36 was considered the first dry nuclear weapon tested by the United States government. Using 2 separate parachutes, the bomb was designed to be airdropped slowly over its target to give bomber crews enough time to escape potential harm. In total, the United States military developed over 940 Mk-36 bombs between 1956 to 1958, with 2 separate versions being developed, including the Y-1 and Y-2, respectively. However, as with most of the United States' early nuclear weapons, the Mk-36 was quickly retired by 1962, being replaced by the far more powerful and destructive B41 devices. Number 6. Ivy Mike H-bomb, 10.4 megatons. The Ivy Mike H-bomb, hydrogen bomb, was a thermonuclear weapon first detonated on the 1st of November 1952 by the United States on Eniwetok Atoll. Designed by Richard Garwin, the bomb was incredibly massive, with a total length of 244 inches, 6.19 meters, and a total weight of 82 tons. The explosion was so powerful and violent that the bomb's mushroom cloud rose to an altitude of 56,000 feet in less than 90 seconds, reaching a maximum height of 135,000 feet. Radioactive debris was reported falling nearly 35 miles away from the blast site, while radioactive fallout remained for several months. The explosion also created two new elements known as Einsteinium and fermium, which were produced around the detonation site due to the bomb's highly concentrated neutron flux. In terms of destructive power, the Ivy Mike was approximately 472 times more powerful than Fat Man, which was detonated over Nagasaki in 1945. Number 5. Mk-24, B-24 Nuclear Bomb, 10 to 15 megatons. The Mk-24, also known as the B-24 or Mark 24, was a massive thermonuclear weapon developed by the United States military between 1954 and 1955. Approximately 105 of these devices were constructed in less than a year and were based, in design, on the Castle Yankee series of bomb tests. As the third largest nuclear bomb, in size, ever constructed by the Americans, the bomb itself was massive, measuring over 296 inches long and weighing over 42,000 pounds. Due to this destructive capability, a 64-foot parachute was specially designed for the Mark 24 to slow its descent and allow bomber crews ample time to escape its blast radius. Number 4. Mk-17 Nuclear Bomb, 10 to 15 megatons. The Mark 17 nuclear bomb, also known as the Mk-17, was the first mass-produced series of hydrogen bombs developed by the United States military in 1954. Although phased out in 1957, due to larger, more efficient prototypes in development, the Mk-17 was an extremely powerful weapon with a yield approaching 15 megatons. Like many bombs on this list, a 64-foot parachute was also specially designed to delay the bomb's descent to Earth, giving bomber crews time to escape the blast radius and initial shockwave upon detonation. With the creation of smaller and more easily transportable bombs in the late 1950s, the Mk-17 was phased out in 1957. Number 3. Texas 21, Shrimp, 14.8 megatons. The Texas 21 nuclear bomb, also known as the Shrimp thermonuclear bomb, or Castle Bravo, was a weapon first tested on the 1st of March 1954 at Bikini Atoll in the Marshall Islands. Housed in a cylinder weighing nearly 23,500 pounds and measuring over 179.5 inches in length, the massive bomb was originally designed as a 6-megaton weapon that used lithium deuteride to power its fission reaction. However, due to errors encountered during its design by Los Alamos National Laboratory, the explosion at Bikini Atoll was nearly 3 times the predicted yield, generating nearly 15 megatons of destructive force, approximately 1,000 times more powerful than the atomic bombs used on Japan during the Second World War. Within 1 second after its detonation, the nuclear weapon formed a 4.5-mile-wide fireball visible over 250 miles away. The characteristic mushroom cloud, common in nuclear blasts, reached 47,000 feet in less than a minute, with an overall width of 7 miles. Nearly 7,000 square miles of the surrounding Pacific Ocean were contaminated with radioactive debris. Number 2. B41 Nuclear Bomb, 25 megatons. The B41 nuclear bomb, also known as the Mk-41, was a 3-stage thermonuclear weapon designed by the United States during the early 1960s. As the most powerful bomb ever constructed by the Americans, the maximum yield of the device was estimated to generate nearly 25 megatons of destructive force upon detonation. Employing deuterium-tritium as its primary, along with lithium-6 enriched deuteride for its fuel source, the B41 utilized nuclear fusion to create its massive yield. Nearly 500 of these massive bombs were developed between 1960 and 1962, before finally being retired in July 1976, following its replacement by the B-53. In terms of power and destructive capabilities, the B-41's yield was approximately 1,136 times more powerful than the atomic bombs detonated in Japan during the Second World War. Number 1. Tsar Bomba, 50 megatons. The RDS-220 hydrogen bomb, affectionately dubbed the Tsar Bomba, was the most powerful nuclear bomb ever built and was detonated by the Soviet Union on the 30th of October 1961 over Novaya Zemlya, just north of the Matichkin Strait. Delivered by a modified Tu-95 Soviet bomber, the bomb weighed approximately 27 metric tons, 59,520 pounds, and was 26 feet long by 7 feet wide. Unbeknownst to the crew, however, Soviet scientists gave the pilots only a 50% chance of actually surviving the blast once detonation occurred. The nuclear blast, possibly reaching a yield of 58.6 megatons, was so powerful that shock waves were felt over 127 miles away by an observation aircraft, a Soviet Tu-16. Although the Tu-95B bomber crew survived the blast, the shockwave caught their aircraft 71 miles away, nearly downing the plane. An experimental American aircraft, known as the KC-135R, was also in the area during the test and was scorched by the blast, nearly killing the pilot on board. Following its detonation, the Tsar Bomba could be seen over 620 miles away and created a 5-mile-wide fireball along with a 42-mile-high mushroom cloud, 7 times the height of Mount Everest, that reached Earth's mesosphere. The existence and proliferation of nuclear weapons stand as a reminder of the profound responsibilities humanity faces in the realm of global security. The top 10 deadliest nuclear weapons presented in this video highlight the immense destructive power at our disposal. They serve as a chilling testament to the capacity for unimaginable devastation that humankind must strive to prevent. The pursuit of disarmament, non-proliferation agreements, and diplomatic efforts remains essential for safeguarding our collective future. It is our hope that through understanding the magnitude of these weapons, we can collectively work towards a world free of the threat they pose and embrace a future built on peace, stability, and global cooperation. The path to a world without the shadow of nuclear weapons is a challenging one, but the stakes could not be higher. The choice is ours to make, and the time to act is now.